All right, we're going to talk about area of a triangle, and most people feel like this is pretty easy, but it gets a little complicated sometimes depending on what the triangles look like. So I have 4 triangles right here, and I am going to ask you which one does not have the same area as the others. Do they all have the same area, or are they all different areas? So let's think about that question. So here are our 4 triangles again, and we're going to take a look at them one by one and see if we can figure out which one, or if any, have the same area. We're going to start with this one. And the reason we're going to start with that one is because, frankly, it's the easiest, because it has a right angle here in the corner, so it is a right triangle. So we're going to start with that one. Okay, so we're going to start with this first triangle right here, which is a right triangle, even though because of the angle of my camera, as you can tell by the sunlight coming in my window, this is a right angle, even though it doesn't look like one, and this is a rectangle. Now, this side right here is the base of the triangle. It's also the same length as the base of this rectangle. And then this side up here is the height. Now you say, well, what about this other side over here? Well, that is definitely not the height, because you would never stand that way when you're measuring your height. So think about how you stand. You stand like this when you're measuring your height. So that's the height. And so over on this rectangle, that is also the height. So why did I bring the rectangle into the picture? Well, because if you were to put the triangle on top of the rectangle like so. Okay, I said put the rectangle on top of the triangle. I meant put the triangle on top of the rectangle. If you were to put the triangle on top of the rectangle like this, it may be easy to see that this triangle here, the gray part, is the same as this leftover part on the rectangle that the triangle is not on top of. And so that's why the formula for area of a triangle is 1/2 base times height, because base times height gives you the rectangle and the triangle is half of it. You'll also see this formula as base times height divided by 2. Same thing. So if you take half of something, you can multiply by 1/2 or divide by 2. Same thing. Okay, so we have established that this right triangle is half of this rectangle. All right, now we're going to look at our second triangle and the same rectangle. So this triangle here is an acute triangle because all its angles are acute. They're all less than 90. And it looks to be scalene, which means all the sides are different. So it's kind of a irregular, if you will, triangle, but it's, kind of nice and neat, all very typical of what an elementary school student would say a triangle looks like. Okay, so I put that triangle on top of the rectangle. So I still have the same base and the same height that I did before. Now this base of the triangle is the same length as the base of the rectangle. Now the height of the triangle would be drawn from the very top, perpendicular down to the base. So if I do that, let's see if this 1/2 thing still proves to be true. So if I were to look at this triangle, I have this section over here, and I've got this gray section and this yellow section. And I think most people could agree that this gray section here is the same size as that yellow section. Let me make my pen a little bit thinner so it's a little bit easier to see. So if I have my height there and my base there, so then my gray section is the same as my yellow section. Same with over here on this side, gray is half and the yellow section are the same. So my triangle is half of the rectangle. So my area is base times height divided by 2. So that means this triangle and the other triangle have the same area. because they have the same base and height, and they're half of the same rectangle. All right, so now I'm looking at this third triangle, and this triangle is acute and scaling as well. It's a little bit closer to being a right triangle because its base and height, its base is here and its height is there. But this angle here in the corner is getting closer to a 90-degree angle, so my height is, so it's kind of a little bit closer there. So if I were to break this up, I have the gray section, the yellow, the gray, the yellow. So that one's kind of similar to the last one. So we'll go ahead and say that this is base times height divided by 2. So it is exactly the same as the other one. Okay, finally we're going to look at this obtuse triangle. It's obtuse because this angle here at the corner is greater than 90 degrees. What bothers people about this one is, unlike the other triangles, the height, when we look at the rectangle, the height like this does not fit inside the triangle. And so therefore, the height is often drawn on the outside because it goes from the very top to the base. And so there are these dotted lines that are formed, but your height is the one that goes straight up, because again, think about how you stand when you measure your height. What bothers people then is they think that they should add this little piece to the base, and they shouldn't because it's not part of the triangle. So the base is from here to here because that is the actual triangle. That dotted section is not the base because it's not part of the triangle. It's only there to show that the height comes down at a 90-degree angle. So even though this height is outside the triangle, it is still the true height, because if you were to move it over, it would still go from, and I'm having trouble moving it, so I'm just going to redraw it. It would still go from the highest point of the triangle to the base, and that's what a height is supposed to be. It isn't necessarily supposed to fit inside the triangle, it's just the measure of the distance from the top to the base. So obtuse triangles have their height drawn on the outside, but that's still okay because that is still the same as the height that you need with your base to measure your area. So that being said, that means that the area of this triangle is also base times height divided by 2. So even though all these triangles looked very different, they all have the same measure base, they all have the same measured height, so therefore they all have the same area. Now you So if you're wondering about the base times height divided by 2 thing, this one doesn't easily fit into a rectangle. I tried even taking it apart and making it work, but because of the obtuse angle, it's just a little too hard. So what I want you to visualize instead, just for the sake of simplicity, is if we were to make a parallelogram out of this, and this parallelogram has the same base and the same height as this triangle. Now you can see that this gray part and this part are the same. So it still does work, even though not as conveniently as the other triangles. So it still is base times height divided by 2. It's just that this obtuse triangle is half of a parallelogram instead of a rectangle. But it still uses the same formula, still has the base and height, still has the same area.